Good morning to all. This is Priyanka. My topic is Principles and Applications of IR Spectroscopy. Contents: Introduction, Spectroscopy, IR Spectrophotometry, Principles of IR Spectroscopy, Applications of IR Spectroscopy. Introduction. Spectroscopy is a technique used to determine the structure of a compound by the study of the interaction between matter and electromagnetic radiation. It is non-destructive. It means destroys little or no sample. Infrared spectroscopy or vibrational spectroscopy is concerned with the study of absorption of infrared radiation, which results in vibrational transmissions. Infrared radiation refers broadly to that part of electromagnetic spectrum between visible and microwave region. Let us discuss about spectroscopy, method of seeing the unseeable atomic molecules. Using electromagnetic radiation to obtain information about atoms and molecules that are too small to see. Spectroscopy is an instrumentally aided study of the interactions between matter. It means sample being analyzed. And energy, it means any portion of the electromagnetic spectrum. Now let us discuss about IR spectrophotometry. Energy of molecule is equal to electronic energy, vibrational energy and rotational energy. IR spectroscopy is concerned with the study of absorption of infrared radiation, which causes vibrational transmission in the molecule. Hence, IR spectroscopy is also known as vibrational spectroscopy. IR spectra mainly used in structure elucidation to determine the functional groups. Molecular effect. These are the molecular effects of IR spectroscopy. The energy will transfer from lower frequency, lower wavelength to stronger wavelength, higher frequency. The principle of IR spectroscopy. Molecules are made up of atoms linked by chemical bonds. The movement of atoms under the chemical bonds, like spring and balls vibration. Vibration of a diatomic molecule approximates an oscillating spring. These characteristic vibration are called natural frequency of vibration. When energy is in the form of infrared radiation is applied, then it causes the vibration between the atoms of the molecules, and when applied infrared frequency is equal to natural frequency of vibration, then absorption of IR radiation takes place and a peak is observed. Different functional groups absorbed characteristic frequencies of IR radiation, hence gives the characteristic peak value. Therefore, IR spectrum of a chemical substance is fingerprint of a molecule for its identification. All the bands in the molecule are not capable of absorbing IR energy, but only those bands which are not accompanied by a change of dipole moment which absorb in the IR region. Such vibrational transmissions which are accompanied by a change in the dipole moment of the molecule are called IR active transitions. Example: C, O, NH, OH, etc. Groups having permanent dipole moment and thus absorbs strongly in the ordinary IR region, but transmissions in the C bond C symmetrical alkenes and alkynes are not having permanent dipole moment and hence does not observe in the ordinary IR region. Let us discuss about the criteria for a compound to absorb IR radiation. Correct wavelength of radiation, change in dipole moment. Now let us discuss about correct wavelength of radiation. A molecule to observe IR radiation, the natural frequency of vibrations of some part of a molecule is the same as the frequency of incident radiation. Now let us discuss about change in dipole moment. A molecule can only absorb IR radiation when its absorption causes a change in its electric dipole. A molecule is said to have an electric dipole when there is a slight positive and a slight negative charge on its component of atoms. Applications of IR spectroscopy are identification of structure, determination, qualitative analysis of functional groups, distinction between two types of hydrogen bonding, study of chemical reaction, study of ketanol tautomerization, non-invasive blood glucose monitoring. It means near-infrared spectroscopy is used across the earlobe to measure glucose. Amount of near-infrared light passing through the earlobe depends on the amount of blood glucose in that region. The earlobe was not chosen due to the absence of bone tissues and also because of its relatively small thickness. Thank you.